Hello, everyone. Welcome to the Masons online classroom. Today, I'll share with you the second part of the commonly used masonry materials, masonry mortar. This session on masonry mortar comprises three main sections, which are 1. Composition of masonry mortar materials. 2. Technical properties of masonry mortar. 3. Mixed design of masonry mortar. Let's begin with an overview of masonry mortar. 1. Definition of masonry mortar. Masonry mortar is a construction material composed of binding materials, fine aggregates, and water, prepared in specific proportions. 2. Key differences between masonry mortar and concrete. Masonry mortar lacks coarse aggregates in its composition, also known as fine aggregate concrete. 3. Functions. Cementation. Mortar securely binds individual units, forming a cohesive structure. Load-bearing and transmission. Once hardened, mortar evenly distributes loads, ensuring the integrity of the masonry. Thermal insulation. Secondary effect filling gaps between block materials enhances building insulation, soundproofing, and moisture resistance. 4. Classification. Masonry mortar is categorized into 4 types: cement mortar, cement lime mortar, and other mortars. Cement mortar consists of cement and sand mixed in specific proportions. It is of high strength and is generally used for foundations, basements exposed to water, and walls subjected to significant external forces. Cement lime mortar comprises cement, lime paste, and sand. Generally used for above-ground masonry construction with good workability. Lime mortar consists of lime paste and sand, relying on lime's self-hardening for strength. Suitable for dry environments or temporary masonry construction. Other mortars includes waterproof mortar, caulking mortar, white lime mortar, and high polymer mortar. Next, let's delve into the first part: composition of masonry mortar materials. Masonry mortar comprises binding materials, fine aggregates, admixtures, and additives. Mortar comprises binding materials, fine aggregates, water, and other materials proportioned appropriately. Sometimes, to improve workability and save cement, a certain amount of admixtures may also be added. As there are no coarse aggregates in mortar, it can be considered a type of fine aggregate concrete. The constituent materials of construction mortar include binding materials, sand, admixtures, and water. 1. Binding materials. Common binding materials include cement, lime, and plaster stone. Considerations when choosing binding materials. 1. In moist environments, opt for hydraulic binding materials. 2. Cement strength should be 4 to 5 times the strength of mortar. Avoid excessive strength. 3. Universal cement can be used to prepare mortar. As far as possible, priority should be given to the selection of masonry cement specially used for masonry mortar and finishing mortar, and special cement should be used for mortar with special requirements. 4. Avoid the use of recycled cement. 2. Admixtures. Types of admixtures include lime paste, clay paste, and coal fly ash. The purpose is to improve workability and save cement. 3. Sand. In principle, the sand used for mortar should meet the technical requirements for concrete sand. For stone masonry, use medium sand with a maximum particle size not exceeding 1/4 to 1/5 of the thickness of the masonry joint. The sand used for brick masonry should be medium. Graining sand should be used for smooth finishing and pointing mortar. 4. Water. Use clean tap water or natural water, similar to that used for concrete. Unverified wastewater should be avoided. 5. Additives. Additives, such as early strength and anti-creaming agents, are incorporated to enhance other properties of the mortar. 2. Technical properties of masonry mortar. The technical properties of masonry mortar include the workability of mortar mixture and the technical characteristics of hardened mortar. The workability of mortar mixture refers to its comprehensive property of being easy to work with during construction and ensuring quality. The workability of mortar mixture includes two aspects: fluidity and water retention. Fluidity, also known as consistency, refers to the ability of mortar mixture to flow under its own weight or external force. Consistency is generally controlled through construction operations. In laboratory testing, it is measured using a mortar consistency meter, indicating the depth to which a standard cone penetrates the mortar surface, known as penetration depth. A greater penetration depth in the consistency test indicates higher fluidity. In selecting the consistency of masonry mortar, it is generally observed that the heavier the masonry, the greater the required consistency. For instance, as shown in Table 6.1, ordinary bricks typically require a mortar consistency of 70 to 90 mm, while small hollow blocks may require a consistency of 60 to 90 mm. The water retention aspect of workability refers to the ability of mortar mixture to retain its internal moisture and prevent leakage. This property is typically expressed in terms of stratification, with a stratification of 10 to 20 mm considered optimal. Factors influencing water retention include: 1. Type and quantity of binding materials. 2. Type and quantity of admixtures. 3. Quality of sand. 4. Type and quantity of additives. Stratification is determined by measuring the consistency of a uniformly mixed mortar, allowing it to settle for 30 minutes in a layer separator, and the 200 mm mortar was removed, and then the consistency of the remaining 100 mm mortar was measured. The difference between the consistency measured before and after is the stratification value of the mortar. For masonry mortar, layer separation of 10 to 20 mm is optimal. Excessive stratification can lead to bleeding and other phenomena, resulting in loss of fluidity, making it difficult for construction. If the stratification is too small, the mortar becomes viscous, unsuitable for laying, and prone to shrinkage cracks. The technical properties of hardened mortar include compressive strength, bond strength, deformability, and durability. The compressive strength of mortar is determined by testing a set of 6 standard cubic specimens, 70.7 mm times 70.7 mm times 70.7 mm, under standard curing conditions, temperature of 20 plus or minus 2 degree and relative humidity above 90%, to measure the 28D compressive strength. The strength grades of mortar are classified into 6 levels: M2.5, M5, M7.5, M10, M15, and M20. The bond strength of mortar is a crucial factor affecting shear strength, seismic resistance, and crack resistance in masonry structures. The deformability of mortar refers to its susceptibility to deformation during the hardening process when subjected to loads or variations in temperature. Excessive deformation can reduce the overall integrity of the masonry, leading to settling and cracks. Simultaneously, mortar should exhibit good durability, requiring strong bonding with substrate materials and minimal shrinkage deformation. Mixed design of masonry mortar. Mixed design of masonry mortar encompasses: 1. Calculation of cement mortar mix proportions. 2. Selection of cement mortar mix proportions. 3. Compliance with pre-mixed masonry mortar specifications. 4. Trial mixing, adjustment, and finalization of masonry mortar mix proportions. That concludes our lesson for today. Thank you all for watching.